My senior project titled Conagra Brands Work Design Improvement for my Tech 4945 senior project. Some of the first things that I did for this project was I established new standard task sheets for the Building 22 department, fish, lines 1 and 2, for the processing, packaging, and material supply handlers. I established some master center lines for the processing product belts by SKUs, line 1 and 2. To do this, you have to determine the belt speeds to establish center lines for all 19 product families that we run. This takes a lot of data points. This is something that you can't just jump into. This is something that you have to gather data to see what your run rate needs to be to reach your target each time. By rolling out new training on these center lines, you have to make sure that the operators and the people who are performing these daily tasks are communicated to well enough that they understand what the task given at hand is and what they need to do to move forward. Here's the new standard task sheet that I created. By establishing these center lines, I was able to actually notice a change in the standard task sheet for the time that it took to do each task. As you can see here, I have it laid out for each task that they have to do to perform their daily jobs. The first thing they do is they put on their proper PPE. Next, they speak with the previous line operators about any issues that they may have, which takes approximately 5 minutes. The next things they got to do is take a battery temp check, and so forth as we go down the list. And that's how I created the new standard task sheets just from rolling out the new center lines. Here's the center line sheet that I rolled out. As you can see here, I have a min-max and a target for each speed, for each belt, and each piece of machinery that the product may touch at any time. I have it laid out from the beginning of the process to the end of the process. Next, completed a detailed fish line structure layout and packaging. What this means is I laid out each piece of equipment and where it needs to be at for the day and where the setup is, and give them an overall visual of how the line should look before they even start their job for the day. And this also affected the standard task sheet, which is also known as a time study, and that was a huge improvement on our year process because the shorter time it takes to do a task, the more product that one can run out. The next thing I did is I included the line setup standards to help verify all settings are correctly adjusted. And by doing this, I mean I labeled all pieces of equipment and I put in floor markings. I set up all types of center lines that would show you where the line needs to be and what the run rate should be set at. And it took away a lot of variance from the operators of what they think and actually what it should be. And this helped us get a more stable run time instead of it just being here and there and being at different times. We was able to establish more of a center line of what the product for each SKU runs most efficiently at. So the next thing I did was I labeled all working parts in packaging area that are adjustable by an operator, meaning anything that an operator could adjust for the day, anything that could be moved, I labeled that so that they knew exactly where that was at in case anybody wasn't there that day or they got a little confused or hectic in the process, and it kind of took away from any operator error that we were seeing. My intentions of this visual check sheet, it gives the operator in the packaging area or whatever work cell that they're working enough knowledge to be able to correctly set up the line without thinking or guessing about where it should be. And this was huge for us as we moved forward for this yield improvement because there was no type of standard that was in place for these operators to know exactly where to set things up at. As you can see here, here is some of the layouts that I drew up, and I also put what the setting needed to be at and how they lined it up. So as you can see here, I have the box chains. The box chains were supposed to be at the align marks. So how I did this is I would etch into the machine a mark, and then I would etch the next step a mark. So so that they knew that, hey, that wasn't just a quick look at it, it was, hey, I need to align these marks. It kind of took away the operator error once again. I keep coming back to that because that was such a huge thing that I noticed when I was observing these people, is that a lot of errors that we come upon were by operators in the future. The next things that I did is I created a visual footprint for the fish production areas. This is also one of those things that it just gave them a visual to look at and let them know that, hey, do I have this line set up? And it was a quick reference point for them to be able to see, hey, this is how the line should be. Now I can look and make sure everything's aligning and everything is set up properly. Took away from any guesswork and any unnecessary downtime. So after doing that in the processing and packaging areas, which are our main areas, not each work cell, but just the overall area, I started doing a separate overall floor plan for the 4 different sections. After doing that, I labeled and documented everything that is critical and used in those areas, production areas. So by doing this, I was able to identify all the critical areas and label everything that needed to be adjusted and set for the correct time. This is the visual footprint that I gave for the overall setup. As you can see here, I have each piece of equipment in each area that needs to be where it needs to be set up at. I also have the 5S color codes in here, which I will talk more about later. This is the beginning phases of laying out 5S, which was a huge key for us to sustain this yield improvement for the future. And it also helped with my standard task sheets in the beginning, because my standard task sheets are also known as my time studies, were lagging, and I wanted to give them a quicker task because a lot of people didn't know where certain tools were, where certain things were laid out. So by doing this, I was able to give them an overall reference of what needed to be where and what is our color codes for each area. Here is one for the packaging area. That previous one was for the processing area. As you can see here, I have everything labeled from the edible toads to the glue pots to anything and where its designated area is. After completing a visual study on the fish slicer magazine and rebalancing the line after I established these center lines and the 5S as I was rolling that out, I was able to notice potential savings in direct labor. With the correct balancing done on the line after adjusting the center lines and doing 5S, that we only needed 3 operators to complete this daily task in step 4. And this one headcount reduction, which we actually did not cut this person, we just relocated them into the plant, was approximately around $140,000 savings for us, which was a huge savings, and there's also a help with our yield process. And I will show that math on the next slide. As you can see here, I went through all the necessary methods to calculate how much we paid that person, and for each step, as you know, Carl Williams really stressed this point to us in his quality improvement class. As you're going through here, you can set up all this stuff and things that you pay these people, from overtime to breaks to this, and it was really able to give us, after an overall view, had to work with the accounting department to really get those figures. But when it was all said and done, it was approximately around $140,590 savings just on this one headcount reduction that was seen from the center line adjustments and the 5S rollouts, because it gave them more of an organizational structure and less guesswork into the operator seat. After doing this, I started collecting more data and performed studies to determine if my center lines I had put out were making an impact on production. And so after noticing that they were making a huge impact, the center lines were, the next step I knew was sustaining. And that's something that my company has always had trouble with, is we roll out all these great tools and implement them on the floor, but they kind of just die out in the future. I didn't want that to happen too. So to sustain this yield improvement, I had to make sure that these center lines were being done. And as you know, we run 3 shifts, which is 24 hours, 6 days a week. So I'm not able to be there and look over their shoulders 6 days a week, 24 hours. And so I come up with the centerline execution health check, which is pretty much an audit that is to be done daily to make sure that our center lines are being executed correctly and implemented as they go each day and not just dying out and being pencil whipped. And so after doing this, I decided that I needed to start a project charter for the yield improvement and processing so I could document all this work, because without documentation, as you know, it kind of things just kind of hearsay, hearsay, and things kind of die out in the process. And so to document this and to really get an overall savings impact, I started the project charter, which we'll see now. Here are some of the defects per minute. This is a sheet that I come up with because after establishing center lines, we were able to notice that we were able to really narrow down our defects. By meaning this is I would do a fish waste stream report and I would catch 100 samples of defects that were being thrown out. And we classified those into 4 different categories: fragments, broken pieces, misshaped, misbatters, and marriages. And each one of these were really, once you figured out the process flow, we were able to see that each one was directly impacted by the belt speed. So after getting the correct belt speed lined out, say if the belts are running too fast and the next previous belt is running slower than the first belt, you're going to see marriages, which is really where 2 fish sticks lay on top of one another and kind of get, run through the process doubled up. And so by setting the correct belt speed, we were able to eliminate a lot of defects. And as you can see, our average went from a 73% defect down to a 49%, which is a huge improvement for us, which was a huge impact on our yield process. Here is the centerline execution health check that I come up with. It is pretty much an audit done by a supervisor or somebody in management that goes through here, and it's kind of a yes/no, and it's a scoring sheet, which you scored on the task at hand. So you go through here and you look at the standard. Everything, you have to create a standard, because there's no standardized work when I started this. I had to roll out standard work. So that means I had to roll out that, hey, this is what we have to do, and this is the standard that will be looked at, and this is the communication of expectation moving forward. So to sustain that, I gave a overall health check to make sure that these operators on the floor were completing their tasks correctly. Here's the project charter that I started. As you can see here, my plant manager was my project sponsor, and the estimated financial benefit for this improvement was around $200,000, and it's actually about $224,000 is what a 1% yield improvement comes out to be. And this just kind of documents the project as it moves forward, so that anybody up in corporate or anybody looking to see what we're doing, we have that documented, and as it goes, it kind of gives the responsibility out to each person and personnel moving forward. So next, I had to do a time study on the tri-seal to verify current standard task sheets. The STSs that you've seen that I completed earlier, time studies, were in the processing area. The way I looked at it is I needed to start at the beginning of the process and work my way forward, or work my way back into the process. Because if you work from the back to the front, you're kind of just stepping on your own toes. So I started at the beginning of the process and made sure I had that process lined out and maximized to its highest efficiency before I moved any farther. So after doing this, I decided I needed to move to the packaging area and start with the tri-seal, which is one of our most critical pieces of equipment that hits us on downtime and unnecessary downtime, which is something that we can eliminate. So after rolling out a new standard task sheet for the tri-seal operators in packaging, I completed another time study for the standard task sheets, because after completing the first one in packaging, I noticed that there was unnecessary downtime for the material supply handlers. This is pretty much just a fancy word for our forklift drivers. I noticed that a lot of times that our tri-seal operators were waiting on cases, cartons, because the material handlers really didn't have a grip on what they needed to have out there and when they needed to have out there. So I collected more data on this because no one had rolled one out for the forklift drivers yet. As you can see here, here's our tri-seal piece of equipment, and here's this new standard task sheet that I rolled out. This is one for the line 1 processing floor layout. After redoing the standard task sheets in packaging, after a couple of weeks, I decided maybe that these operators had gotten better at their jobs, better at their duties, and they had gotten more comfortable with the task at hand. So I went back and collected more data points to see if we were executing correctly. And as you can see, each task gets faster and faster as they went. So that tells me that my center lines and this 5S rollout is really making an impact on our standard task sheet, which overall impacts our yield. After doing this, I implemented another study. As you can see here, I did a lot of data collection here and did a lot of studies because that's really the only way to get to know the process. It's going down to the floor, collecting data, and just put your boots on the floor and observe. Because without doing this, without a full understanding of what you're doing and what you're trying to accomplish, you're kind of just, walking on your own feet and you're kind of backtracking as you go. So this was one of those things that I learned from, is you kind of have to work your way forward and line out each process as you go, instead of just kind of jumbling around and laying out a plan that is correctly done before you implement the next step. So I proposed a 3% yield improvement, and year to date we were setting at this point at 2.74. A 1% yield improvement, as I mentioned earlier, is approximately 225,000, in which it's really around 224,000 with the headcount reduction. So trying to push out the last 0.2% was really difficult, but we are slowly moving in that direction. I did end up reaching a 3% yield improvement. This was just a documentation PowerPoint that I was laying it out as we move forward, and you will see that as I go. Should I reach that target by mid-March, which gives me nearly a month and a half to work on my paper, and I started implementing 5S more to sustain. Here's another data study and observation that I did on the defects per minute. As you can see here, we went from a 73% down to a 42% this time. The initial line study was done on line 1 that you've seen earlier in my PowerPoint, and this is on line 2. And the center lines are making huge impacts on your defects, which overall impacts your yield, because waste, impacts your yield completely. That's one of the main things in your yield is zero loss yield and loss to standard. And so now, from going from loss to standard, we were able to drop that down tremendously. Finished up on my 100% completion of the 5S targeted areas in my department: processing, packaging, and the mixing areas. Those are our 3 major areas in our department. So by saying this, I'm trying to implement a quicker standard task sheet, because after rolling out center lines, the only thing I could do now was to implement a faster time study to get things lined out as clearly and as detailed as possible. So every single piece of critical equipment and production process was properly labeled and stored in the designated mark location. Also, anything that directly touched the product or anything that was movable within the work cell was also marked and labeled according to Conagra's color code standards. Red was trash, white is an edible production, gray is non-edible production, also waste, and blue is productive equipment, such as the machines that are actually moving the product down the line. So after beginning working on the integration of line 2 to kind of streamline that process, all production belts in processing. So by doing this, we were having to go in and adjust the drives on the Allen Bradley skip out that. We were going in and adjusting the drives manually on the pod. So I wanted an easier visual instead of having to call maintenance every time that an operator needed to make a belt adjustment. I had everything put in on an HMI. This was a huge project for us. I had to have operations involved, I had to have maintenance involved, and I had to have control techs involved. So to get this on an HMI, we hooked everything directly up to the control panel and had it all on a nice computer screen right there. So instead of them going in and adjusting the frequency of the drive, they could type in the speed that they wanted, and each belt would start up automatically and go through its own process. So this was a huge, huge impact on our yield. So after this, I decided to bring the operators in more onto the process. To get them to buy into the cultural change and the environment change, I asked them for some of their opinions. And after getting some of their opinions on the center lines and how each SKU needed to be different than one another, I completed more studies to collect data for new line speeds because we were able to run faster because the operators were more comfortable with their job with everything being lined out for them. And we were able then to hold the operators accountable for these jobs instead of them just saying, I didn't know. Well, now you know, and now you have that communication of expectation moving forward. And everyone would be held accountable by doing these centerline checks. And to hold them accountable, that's why I had to bring in the centerline health check audit. And another thing is that we were searching for tools, as I noticed in my time study. As the beginning of the process startup, since we're a food manufacturer and we have to go down and clean a lot, I noticed that we were searching for a squeegee, we were searching for this, we were searching for a scraper to get the line set up. So I decided to come up with these tool racks and make shadow boards for them so they knew exactly what the location of the tool was and where it needed to be hung. Here is some of the beginning phases of me rolling out these center lines. As I would lay out the line process, I would go through with a tachometer because the frequency on the drive really didn't tell us the speed of the belt. We just know that it's running at 32 hertz. That doesn't give me a speed. So I went through and put a tachometer on each belt to really understand that speed of that belt, because what you want is you want a 10% carryover as product flows down the line. As product flows through the process, if each belt is set at a 10% higher rate than the next, that product flows more smoothly. And this goes back to my center lines and the defects. As product is moving forward at a 10% rate, it pulls that product along and you don't see your marriages and you don't see your fragments from getting hung up on the belts and going out. You don't see your misshaped, misbattered fish because it's actually going through the process and underneath the batter applicator belts at a more rate that is acceptable for its maximum efficiency. Here was the actual centerline documentation on the floor. I printed these documents and I had them by each SKU, as you can see. And what I would do was I grouped the product families on each SKU that ran at the same speeds. And this is what was on the floor for the operators themselves. I felt like this was key to put on here because instead of just, they don't have an Excel sheet on the floor to type this into. So what I did was I laminated this centerline sheet and had them document each day the date and what the centerline was running at. And if it was out of line, they were to log that in a deviation log so we could go back and track why they had to go out of line. And it was able to give us more of an understanding of when things were getting, wore out or broke down, or when things in the process were coming to a halt or something needed to be changed. Here's one that it's filled out. I have shift 1, shift 2, shift 3 because we run 3 shifts. And this is their documentation of what everything is set at. And I felt this was critical to put in here so that there was a more understanding of what this actually was on the floor, because we can roll out all of the center lines and all the implementation of tools that we want, but the people actually performing these tasks are the operators on the floor. So it is critical for them to understand what they're doing and how they're going to do it. And I felt this was the easiest way for them to do that on a lamination sheet, to document it for each day so I could go back through and check that and kind of supervise that process. Here's the fish waste stream report that I recreated. This is from an observation where I would go through and I would do a study on the 100 defects that I would catch coming out of the production system relief job. What they do is they sit there and they scan through the fish and they throw out any defects. So as I would go through here, I would go fragments, as you can see in the bottom left corner. The next is misshaped, misbattered, which is in the top left corner. And in the top right corner is your marriages. And then I noticed another defect that was getting thrown out, which is really not a defect when it comes down to it, but it's good fish. And what I noticed from that is the reason good fish is getting thrown out is the operators are sitting there since we have these center lines now and they're not seeing as much defects. They felt like they needed to be doing something. So they were just picking through and picking fish sticks up and throwing them out. So after having this was another training session that I was able to have with the operators to tell them, hey, just because you're not seeing as many defects as you're used to seeing, doesn't mean you have to be throwing things out. And so this fish waste stream report was really key for us finding that, which was also a huge yield improvement. So for each day I would do this, I would come up with the total numbers of defects that I would have, and I would come up for a corrective action for each one to fix that. Here's the shadow boards that I come up with in 5S. This was key to us improving our standard task sheets. As you can see, it has the broom, the squeegee, and the shovel laid out, which is for everyday processes that they use on the floor as tools to complete their jobs. And here is my 5S. Also, I called a health check audit to make sure that that sustainment piece was really done. Because after the center lines being rolled out, 5S was key for us to keep this up. Because if our 5S is being done, we are able to perform at a higher rate, which I noticed was actually that last 1% of yield improvement that I needed to reach my target of at least a 3% yield improvement in the production areas. So this was a key piece for us to make sure that 5S was being kept and that our center lines were being kept also. And that's pretty much what I have in a nutshell for my project. Thank you very much.